Hi guys, today class we see how to design comparator, 2-bit comparator. This is the circuit diagram of comparator. If A is the one bit and B is the another bit, A bit will be checked with the B bit LSB and B bit LSB will check with the A bit LSB and A bit MSB, most significant bit, and A B most significant to check. Okay, so like that, if A is greater than or B, or A equal to B, or A lesser than B, like that it will check. Okay, so this is called 2-bit comparator, magnitude comparator, and this is the truth table of the comparator. In this truth table, if you come to know that 0 0 A significant LSB bit A 0 0, then 0, then A equal to B is 1, like that it will check and it will compare the each bit of the A and B. Okay, so now let we move to design. Okay, so this is the Xilinx ISC 14.7 platform. Here only we are going to design the 2-bit magnitude comparator. So first click file. In this file you see new project. If you click the new project means here you are going to give the file name. Okay, I'm give comparator. Okay, here you are going to give file name, give next, and here you are going to select the which FPGA you are going to use and the speed of the process and the VHDL language. I am going to use VHDL language, so I am selecting the VHDL language. If you want to design the circuit in Verilog language, means I want to select Verilog. Okay, I am using VHDL language. Okay, so give next and finish. Here just click here we created the file name. Now we want to add the source file. Okay, so just right click the file in comparator and give source file. Here which module I am selected is VHDL model because I chosen VHDL. Okay, so here I want to give the source file name, just comparator with the source file name. So I'm going to use 2 input, okay, and 3 output, C, D. This one will be greater than, equal to, lesser than, like that 3 output. Okay, so here I'm using 0 to 1 and also this will be 0 to 1. Okay, I want to change the direction of the output, will be out, out, out. Give next, finish, then the port map declaration will be over. Okay, now here only we going to develop this code. Okay, so this is the library function and values. Okay, which A, B, C, G, E, L, these are we going to use the input variables and output variables also we declare. Now we are going to design the comparator. So if you check the comparator circuit is this one. If A is A greater than B lesser than B is A naught and B. Okay, this is the formula. So if you check means L not and B. Okay, so we want to check whether this one is right or wrong. Okay, so next we are going to use A equal to B. A equal to B will be the E. If you take E equal to not A and B, okay, B and not A and not B. Okay, next we want to give this in temp and equal to x nor. Okay, nor, not x or nor. Okay, we design this A equal to B like that. So just to give the another temp 1 in out, because we're going to use bidirectional logic. Next one, temp 2 in out logic. Okay, so if you check, this means temp 1 equal to not A and B. Okay, two will be A and not B. Okay, now temp 1 not temp 2. Next, greater than will be the A and not B. Okay, so we developed the code. Now we want to check whether the code is what we developed it right or wrong, and we want to check the RTL schematic, circuit diagram and LUTs table, and also the area, power and delay. Okay, so now we check the syntax. First we want to save. So code is running. So I'm getting some error. So now we remove this one. Okay, because we're using single bit, we check with the single bit. Okay, first next we move for the 2-bit. Okay, now there is no any error. Next we check the RTL schematic. So we designing the single bit comparator, single bit magnitude comparator. So if this is the circuit diagram, RTL schematic of the comparator. Next we check the technological schematic. This is technological schematic. Here we came to know how much LUTs we are using. We using 3. If you check inside the LUTs means we will get circuit diagram, schematic diagram, equations, truth table and came up for each LUTs. After that we want to check the area and the delay, right? If you go this one, we using 3 LUTs uh, 3 7 input output bounded. Now we check the 7.914 nanosecond. Now we check the static power that will be inside the place and route. So today class we checked for the single bit comparator, magnetic comparator. Next we go for the 2 bit. Okay. So to run the power distribution, we want to do mapping, place and route, and translate. Okay. So now place and route is running. So finish. Now X power analyzer is window will be open. So this is the Xilinx X power analyzer window. So the power will be 0.060 watt. So next we check the simulation and we create the test bench. To create the test bench, just right click and give new source and check VHDL. Click the VHDL test bench and give the file name comparator and -tb. Like this only we're going to create the file name for test bench. So what is test bench means? We will give the clock signal and the input and output values for the code for the comparator what we designed. Okay. So already inbuilt, we will remove this one. Clock process. Okay. So we know A is the input 0 0, B is the input 0 0. So this is the time period, clock period, and another one is 0 0 1 1 0. Next is 1 1. Okay. So the save and run the simulation. Okay, if there is no any error means simulation window will be open. Then we will check the output. So there is no any error, so simulation window will be open. So this is the simulation window. Here we'll check whether the input is right or wrong. So if we check means A is 0, B is 0, so equal to is 1. A 0, B 0, so A less than B is 1. A 1, B 0, so A greater than B is 1. So A1, B1 again equal to 1. So what we designed is right. Okay, today class we designed the 1-bit magnitude comparator, and we next class we see it for the 2-bit magnitude comparator. Okay, thank you.